Welcome to qnawire.
In this problem, we need to solve for the height to which gymnast A will rise. So I have here a sketch of the problem. So gymnast B with mass MB jumps and falls from a height h and strikes point E with a velocity v1. So this causes the plank to rotate with angular velocity omega, as you can see in the last part of the sketch, and point E to move with the velocity ve downward, and point C to move with the velocity vc upward. So this will send gymnast A off into the air. So let's write first our given values. So we're given the masses of the gymnast A, gymnast B, as well as the mass of the plank. So MA is equal to 55 kilograms. So this is the mass of gymnast A. And then MB, mass of gymnast B, 70 kilograms. And then MP is the mass of the plank, 15 kilograms. Okay, so let's start first with some initial calculations. So the moment of inertia of the plank, given its shape, is given by, so I equals, so 1 over 12, the mass of the plank, times the length of the plank, which is equal to 2L. So that would be 2L squared. So the moment of inertia is equal to 1/3 mass of the plank L squared. We can also calculate already the velocity at which the gymnast strikes the plank. So this would be our V1. So since gymnast B sort of fell on the plank after he jumped at the height h, so the velocity v1, so which is his final velocity, can be calculated using the equation. So v1 equals square root of 2gh. So that would be, so 2 times 9.8 meters per second squared times h, which is 2.5 meters. So this is equal to 7 meters per second. Now, since the linear velocities can be expressed in terms of r and omega, so we have vc and ve. So vc is equal to L omega, since point C is at the distance of L from point D, which is the point of rotation. And then VE is also equal to L omega, because again, point E is at the distance of L from point D. Now, solving for the moments about point D, taking the counterclockwise direction as positive, so we'll have the equation, so M E V1 L plus 0 equals M E V E L plus MC VC L, then plus I omega. So substituting our expression or equation for VC, for VE, and for I, which we have written earlier, so this will become, so M E V1 L equals, so M E L squared omega plus M C L squared omega plus 1/3 MP L squared omega. So simplifying this, so we'll get, so M E V1 L equals, so let's factor out omega. So omega times M E L squared plus mc L squared plus 1/3 mp L squared. So, solving for omega, so we'll see that omega is equal to, so me v1 all over, so L times, so me plus mc plus 1/3 mp. There, so that's our expression for omega. Now, when the end of the plank, which is the point C, rises as a result of the impact of the gymnast B, so it will send gymnast A, again, off, flying into the air. So with a velocity Vc, directed upward. So, since at the maximum height, the velocity is 0, so because what we're actually getting here is the maximum height. So since at the maximum height, the velocity is 0, and Vc is sort of our initial velocity here, so we can get, or the equation for Vc would be, so Vc Vc is equal to square root of 2g hc, where hc is the height reached by gymnast A. So, since we now have an expression for omega, we can now solve for Vc. So, Vc, using our equation earlier, Vc equals L omega. So, we can replace omega with our expression earlier. So, this would be, so L times MEV1 over L times ME plus MC plus 1/3 MP. So, of course, this will cancel out the L. And take note that our ME here is actually the mass of gymnast B, and then our MC here is the mass of gymnast A. Hence, so Vc is equal to, so using our equation here, so ME is 70 kilograms times V1, which is 7 meters per second. Then all over, so 70 kilograms plus MA is 55 kilograms. Then plus 1/3 of the mass of the plank, 15 kilograms. So this is equal to 3.769 meters per second. So that's the velocity of point C, or the velocity of gymnast A. Now, solving for HC. So HC is equal to VC squared over 2G. So this would be 3.769 meters per second squared over 2 times 9.8 meters per second squared. So we'll get 0.725 meter.